Hi, my name is Hye Jung Yoon and I'll be talking about continuous probability distribution. These are the key points to remember about continuous probability distribution. 1. They are denoted by fx, which is called density function, and 2. The graph of the density function is called the density curve. 2 points about the density curve is A. The curve cannot go below the x-axis, and B. The total area under the curve will equal 1. Here are some examples of finding the probability. The probability that random variable x is greater than a but less than b is shown in blue. The probability that x is less than a is shown in red, and the probability that x is greater than b is shown in green. Here I have an example with a triangle about the concept of finding the probability by calculating the area. With this triangle, the probability that random variable x is greater than or equal to 3 can be calculated by subtracting the probability of x less than 3 from 1, which is the entire triangle. The probability of x less than 3 can be calculated by finding the area of the triangle. Here I have the formula for the area of a triangle. We want to find this dark red here, so we want to get rid of this lighter shades of red. And so this triangle, to find the area, we're going to use the base, which is 3, the height, which is 0.375 times a half. And we get the area equals 0.5625. And we subtract that from 1 because we're going to get that area. And we end up getting the area to be 0.4375. I have a similar problem, but we're going to use a little bit different technique here. Probability of x being greater than 1 but less than 3. So we want to find the area right here. But this is a trapezoid. We can use the area formula for a trapezoid, but if you want to find it by using the formula of triangles, then we can use the same thing. Since we already know the area of this triangle right here, 0.5625, we only need to find that little piece right there. And if we subtract that from this big triangle, then we'll be able to calculate this area right here. So we do 1 times 0.25 times a half, and we get 0.0625. So 0.5625 minus 0.0625 will give you 0.5, and that's the area right here. In the uniform distribution, instead of triangles, we use rectangles. It's called a uniform distribution because the height remains the same all throughout. It's centered at the mean. Here it's 5. Let's say that we didn't know the height of this graph, but we know the range, which is 7 minus 3, that's 4. The height can be found just by taking the reciprocal of the range, which is 1 over 4. Some important formulas to remember are the mean and standard deviation. The A and B indicate the endpoints of the interval. Now for the normal distribution. These deal with things like height, weight, and scores. The curve will look like a symmetrical bell curve. Remember that the probability under the curve has to equal 1. So if the standard deviation increases, then the curve will become shorter and widen. If the standard deviation decreases, the curve will become taller and narrow. The standard normal curve is a type of normal curve. Its mean is always at 0, and its standard deviation is always at 1. And here is the formula for the z-score, which I will talk about in a moment. The z-score. The z represents a variable whose distribution is described by the standard normal curve. So its mean is at 0. We can use the table of standard normal curve areas, which can be found at table 2 in the appendix of our textbook. The z-score tells us how many standard deviations the value is from the mean. The total area is hard to find under a curve, which is why the z-score and the table are so helpful. The table shows us the probability, which is equal to the area under the curve. Here is a sample z-score problem. Scores on a math test have an average of 85, with a standard deviation of 4. What is the probability of choosing a student who scored over 90 on the test? First, we have to find the z-score. If you plug that in, it's 90 minus 85 over 4, and we find that z equals 1.25. If you look on the table, it'll come in a column and a row. On the column, we can look for 1.2, and on the row, we can look for 0.05. And if we match those two column and row up together, we'll find that the probability is 0.8944. But this value is the cumulative value from here to here and not this area. So we have to subtract that from 1 and we get 0.1056, otherwise known as 10.56%. You could be also asked with the random variable to be 81 instead of 90. So if we plug in 81 over here, it'll be 81 minus 85, which will give you a negative number. The table usually don't show negative numbers, but you can still look up the absolute value of that z-score that you found. And so you'll be looking at the table backwards. So if it's 81 is right here, then it'll be taking the cumulative value of here. And if the question asks the probability of choosing a student from this area, then we would just do 1 minus the area that we found right here. The z-score deals with the whole curve. However, the empirical rule is a fast way to calculate the probability, but it only works with certain standard deviations. If the interval of the probability is within one standard deviation of the curve, right here, then the total area is 68% of the curve. Likewise, if it's two standard deviations, 1, 2, and 1, 2, so this whole area over here, it'll be 95%. And if it's three standard deviation from the mean, 1, 2, 3, 1, 2, 3, so this area right here, it'll be 99.7.